Hello, today I'm making a video about this healthcare cost navigator. It, think of it as like kayak, basically, but for hospital bills. So the user can basically type any type of natural language, like who has the cheapest hip replacement, let's say in Texas, and go ahead and ask. Yeah, so while we wait here, and then we can see here, we get the results as users use it, and there is a successful template used. You see, we have 167. That template will be added, the SQL query. So we can see here, yeah. So I think this matters a lot because healthcare pricing is really big. It's kind of a black box. So turning like opaque customer management software files into like conversational experiences is really big. I think nowadays, especially with basically we've got queries on 2.7 million rows, finishing under half a second. Honestly, the real wait time that you see is from the OpenAI calls. So we have two OpenAI calls, one for grabbing the template, and then one for doing the AI response. The AI response usually takes about 2 to 3 seconds. Obviously, we would use some type of global CDN, Edge, serverless Edge for OpenAI calls to make this faster. But the query speed is very good. So yeah, we get here. Yeah, so sometimes the DRG codes are not exactly as the procedure name. The procedure names for the DRG codes tends to be kind of confusing, but we do see a liver transplant here. Obviously, they cost a lot. Heart transplant, yeah. So we got here. Yeah, none of this is hard coded. So even example questions are not hard coded. Yeah, so you can see a little front end bug issue. Volume will be here as a dollar sign. This is actually 979, but yeah. So this New York hospital does a lot of major hip and knee joint replacement. Pretty cool, pretty cool. Here we can go ahead and do some type of criteria, maybe like 7 minimum rating. Let's just take um, what was this, 470 DRG code. I'm gonna take this. Let's see if there's anything under 40,000. So yeah, so this, as you can see, is very fast in terms of query. 3,000 providers. So yeah, so we can see some of these right here. And then pulling this off is mostly with smart reuse. So it gets faster every time because the embeddings and the caching system, every valid query that comes through from a user that has some type of result is being saved in the database to be retrieved later on. Of course, this is all retrieval augmented generation. Um, I also got an SQL layer which read only. I use a package called SQL Glot. So the model never, it's impossible for it to drop tables or do some type of, adding to the database, right? Only reads, no writes. Um, yeah, so we got a Docker compose up. So just kind of, you just get in and start it up, right? I think within 2 to 3 minutes, I can start this up right on my computer. Postgres server, backend server, and yeah, works nicely. So I think with this, I try to kind of bridge the product intuition, like let's hide the DRG codes from humans, right? Like these DRG codes, I don't know what the hell they mean, but um, yeah. So it's just with system thinking everywhere, we can reduce these inconveniences, and with async and vector indexes, we make it very performant. And the cost is, I mean, superb. If it wasn't for chat completions with OpenAI, it would be at less than a hundredth of a penny per query or so. All it is just embeddings coming in from the user right here. and then the nightly embeddings for like new data, right? So we have embeddings for like each procedure, right? So we can semantically match the procedure to, like, let's say hip replacement, right? That's a procedure, right? So it all does that kind of intelligently, um, and of course, like building fast, right? So I kind of built this in 6 to 8 hours, kind of full pledged backend, full stack application, um, and very good query results, right? Like, even cosine search with the vectors is under 10 milliseconds a lot of the times. So, like I said, not only speed, performance issues, the completions, the response right here. Um, and we can bring that down, right, through hosted open source models, like I said, serverless, edge functions, things of that sort. Get those OpenAI calls close to the user as possible so they can get that latency down. But yeah, that's about it. Thank you for checking out the demo.